Hi, everyone. My name is Jingbo Xu from the GraphAr team at Alibaba. Today, I will present our latest project, Apache GraphAR, an open source standard file format for graph data storage and retrieval. Graph data is everywhere, from web to gene analysis to social network and knowledge bases. All of these applications are rely on graph structures. On the graphs, the computing workloads are also diverse. There are iterative graph analytics like PageRank and label propagation, and graph querying and traversal, which only touch a portion of the whole graph, and graph pattern matching and graph learning. To handle the various graph computing workloads, many graph systems that have been developed, such as graph DBs, GNN frameworks, and graph computing engines, knowledge bases. This slide names a few. Each of them may be designed for specific tasks. However, in real-life scenarios, the systems often need to cooperate with each other. And sometimes users may want to migrate their data from one system to another. So this raises a question: how do they share graph data? Currently, users rely on the system-specific tools or write their own I/O adapters, also system-specifically, which will lead to a complex M times M integration challenge. We propose GraphAR try to solve this problem. So what is GraphAR? GraphAR is the short for Graph Archive. It is an open source standard data file format for graph data storage and retrieval. It is designed for serving as a standardized file format for importing, exporting, and archiving of graph data, which can be used by existing systems. In addition, it also can be used as a direct data source for out-of-core graph processing applications. The key features of GraphAR include these. Firstly, it is the Apache incubating project, so it is open source and vendor nature. Secondly, the file format supports the property graphs and the common used representations like COO and CSR and CSC. It is compatible with existing widely used file formats, including ORC and PACWAC, and less ideally CSV. The Apache Spark can be utilized to generate and load or transform GraphAR files, and it is convenient for use in both single machine and distributed settings. Lastly, it enables users to conveniently perform operations that without modifying the payload files, just handle the metadata. Next, I will introduce the design of GraphAR with a running example. Here is a property graph with two types of vertices and three types of edges. Firstly, each type of vertices will organize as a logical table, and we will assign each vertex with an internal vertex ID. To quickly access the vertex, the logical table will partition into physical tables with a fixed chunk size. In this example, the chunk size is 500. And then the columns will be divided into column groups to reduce the redundant access of unnecessary columns. In this example, the first name, last name, and the gender will divided into the SAN calling group. GraphAR will record all necessary information for the graph or vertex and edges. In this example, is a person type of vertex metadata, and the payload files will stored separately, and it will be organized like this. Similarly, the edges of the in the GraphAR will also organized as a logical table, and to build the graph from the storage files quickly, we record the offset, the start vertex of each edge, just like the CSR and the CSV data format, using an offset array. Similarly, the logical table of the edges will divide into several physical tables of edges like this. And users can choose the edges sorted by the source or ordered by destination, or leave it unsorted, unordered. Yes, and the edges also has a metadata, and the file layout will be like this. Next, I will show some application scenarios of the GraphAR. The first example is using GraphAR as a graph data source. GraphAR project also provide a collection of libraries for to read and write the GraphAR files. In this example, users can use the GraphAR Spark SDK or GraphAR C++ SDK to build the graph from GraphAR files, and used by the graph systems like Spark GraphX and Boost Graph Library. In addition, users also can use the streaming API of the GraphAR C++ SDK to access the vertex and the edges on demand, and used by the out-of-core graph algorithms. The second scenario is using GraphAR as the archive of GraphDBs. GraphDBs like Neo4j or Nebula Graph can use their Spark connector to export their data or archiving their data to GraphAR files. And then GraphAR files can use the GraphAR C++ SDK to rebuild the graph in other systems, like GraphScope or Boost Graph Library. The third example is the GraphAR can speed up the graph transformation. Here is also an example we used in Alibaba. The original data is stored in warehouses or data lakes at Alibaba, and we use the GraphAR SDK to generate the vertex data and edge data. Then in the graph system, in this scenario is the GraphScope. We will build the graph with GraphAR files. Like this, we build several graphs with the same data set, but choose the different vertex and edges. So in this example, GraphScope only need to write the different metadata, but using the same payload files to build all of these graphs. The future plan of GraphAR is we want to support more data format. We want to support more graph features like RGF and time series data. And we want to optimize the encoding and complete the Spark suite for transform and create GraphAR files. And we also want to develop more integrations with the popular graph systems such as Neo4j, Nebula, 2Graph, or PyG, and other systems. We also want to explore the use of GraphAR for data lake of graphs. Yeah, we also welcome to join forces with us. Yeah, this is the website of the GraphAR project, and it is initialed and donated by GraphScope. Thank you.
Any questions?
So what's the difference between the GraphAR and the CSR format?
It is Graph first as treat Graph as a first citizen. It has some schema, has some metadata recording the schema, and more importantly,
CSR.
CSR. CSR is just one structure of this data. Yeah, it's only recorded topology, but and this GraphAR format is designed for store the whole property graph. It can also recorded all the property columns.
And do you assign a unique ID for all the vertices?
Yeah.
Okay.
Within each type of within each type.
Yeah.
Or label. Yeah.
Okay. And you said it's compatible with Parquet. Do you mean you use Parquet to store the columns?
Yes. Okay. Sorry. In this slide, we assign each vertex a unique ID, like this internal ID.
Okay.
Yeah, it is in a very early stage, so we may not consider very major about for example, how to store the index, for example, but we try to address the other issues in the archiving.
Yeah, can you show how you store the edges?
Edges, yeah. Yeah, this one, or next page, which one?
The prior slides.
Previous slide.
So separate the attributes from the source destination pair.
Yeah. Seems we have a concept is the column group. In this example, since the property only have one property is the creation date. So in this example, it's very simplified. Yeah, it is separated into two column groups, or maybe one column group. Since source and destination is essential. In the edges, in the vertices example, here we have only one column group. In this column group includes 3 columns. Seems maybe users define this. Seems he want to build the graph without property, or some situations in some other situations he want to build the whole property graph. So he tried to separate this, but this is definable by users. This property group included 2 properties. The first is ID. The second property groups, he grouped 3 properties into one property group.
Okay, thank you.
Thank you.
A couple of questions. Do you try and identify situations where a node, the actual values of the labels and properties on a node are repeated across different nodes and optimize that away? So you sometimes get situations where effectively the value of a node is repeated in many nodes, and it's really only one node that's actually being recorded. Do you deal with that?
No, not yet.
You know that. You know that problem.
Yeah, I know, especially the gender, right? the gender property. Only two types.
And it could be more general than that. Yeah. So I had two other questions. One is you handle labels as well as properties. Is that right? Or,
yes.
And could you show the slide where you have the data lake, then you have the archive representation, then you have the graph system. I think it's this one.
This one, yeah.
So there are two mappings there. Let's assume the data in warehouses or in data lakes is actually tabular data, yes?
And yes. Here is the tabular data.
Yeah, and then you graphize it in the sense of saying this is going to be a vertex, this is going to be associated with an edge.
Yes.
So there's a mapping there. And then there's a second mapping which you show, which is almost like a view over that data to actually say, let's look at it as a graph, yes?
Yes.
Do you specify the language of those mappings? How do I state mapping from the warehouse to GraphAr, and how do I state mapping from GraphAr to Graph1? Is that something that's part of your project, or?
Not yet. Sorry. Currently is using the SDK and the metadata and the metadata file. Yeah, users first editor the metadata manually, and then pass the metadata to the SDK. The SDK will build the graph 1, 2, 3. Currently, it's not a language, specific language.
Programmatically, you do the metadata editing, and then you have to carry out some kind of loading operation, or there's some kind of mapping operation using the SDK. Yeah. Okay.
Someone is using the SDK. We're using this SDK to here is a Spark job. In this way, is a GraphScope loader job. Yeah, these two may run on different systems.
Yeah. So I guess one last question. It's very common to have a pattern where the presence of a label indicates a set of labels and properties. It's effectively a key, yeah? It's an identifier for a type, yeah? So there's lots of things that you could do if you have that mapping mapped once, and then you understand that and let things be driven by labels. Do you handle that at all? Do you think about that aspect? So you have a label, maybe it says user, everybody knows that with user, I get these 5 properties. I may have another label or 2 labels that may be associated with, maybe there are tags that I can put on user. So if I know user and I know that relationship, I know a lot about what's going on. I can actually only record, some of the information may actually be, like the labels could be recorded once because I've got it, it's at a schema level. So I'm just interested in how, either now or in the future, are you looking at those kinds of sort of increases in the sophistication of the schema information?
Okay. Currently, it's not. Maybe this is a good future direction.
Yeah. Okay. Yeah. Very interesting.
Yeah, we think
project.
It's very useful.
Yeah. Thank you.
Thank you. Thank you very much.